Good morning, students. Next topic in physics is friction. It is a force which opposes the relative motion between the surface in contact. Friction is a force only, and it is also called as a contact force because it acts between the surface in contact. If you are trying to push the object by keeping on the other object surface, this is the external force you are applying. Then the interlocking of the roughness of the surfaces takes place one over the other, which does not let the object to move. If you extend this external force starting from 0, if there is no external force, there is no opposing force, means the friction is the one which is opposing for this object to move. The external force, if it keep on increasing, at a particular point the ruptures of the surface, rough surfaces takes place and object starts sliding. When the object is still at rest and ready to slide, the friction is called as a static friction, because static means stationary, and ready to slide means same static friction is called as a limiting friction. We take it as Fl and Fs. And static friction, from the beginning, if you have taken external force is 0, static friction is also 0. So, the graph if you check up between this static friction, external force and frictional force, this is the external force, this is the frictional force. As the external force is 0, there is no friction, you should not consider on the level surfaces, and external force increased, friction force also proportionally increases, called as self adjusting force as long as the object is at rest. If the external force is 2 newtons, friction force is also 2 newtons if the object is at rest. If the external force is 3 newtons, friction force also become 3 newtons if the object is at rest. Proportionally, the friction force increases, that is called as a static friction, called as a self-adjusting friction force, which almost automatically becomes equal to external force. And when the object is ready to slide, that friction we are calling that as a maximum static friction, called as limiting friction, but still we take the symbol with Fs, F subscript S, or L, we take L for limiting friction, that is a maximum static friction. From there object is ready to slide, and after that what happens is the object starts sliding. Once the object starts sliding, the frictional force is called as a kinetic friction. Kinetic means motion, in motion, and friction is called as a kinetic friction, or called as a sliding friction, or called as a dynamic friction. And the kinetic friction is less than the static friction, called as a limiting friction. We can say kinetic friction less than limiting friction. This is for the object which are sliding and ready to slide. So, any frictional force if you take, that is proportional to normal reaction. On the level surfaces, normal reaction, level surface if you take normal reaction, n is equals to the weight. Weight is the action, gravitational force, and normal reaction n is equals to becomes equal to mg on the level surfaces. So, this frictional force, whether it is static friction or kinetic friction, what you take is proportional to normal reaction. Proportional to, if you remove, you will get the constant, that is called as the coefficient of friction. It depends only on the nature of the surfaces. Coefficient of friction generally will be less than 1, but can reach to 1 depending on the roughness surface. If the theta is equals to, I mentioned theta here, okay, leave it. This coefficient of friction can be exceed 1 also, and but most of the cases, practical cases, what you find is less than 1 only. N is normal reaction for the level surfaces, only level. Inclined surface, N is a different formula we will take, we will discuss that later. And if it is the kinetic friction, this Fs replaced with Fk equal to mu k into N. This is for the sliding, trying to object to sliding, and this Fs is less than Fk, Fk is less than Fs, and therefore automatically mu k, coefficient of friction for the kinetic, is less than static frictions. And frictional force, which is due to the motion, when the object is in motion, friction do not depend on the velocities, and friction do not depend on the surface area. These points are important ones. And the provided velocity is not too high. If the velocity is too high on the surface due to the roughness, the heat is produced, called as the thermal locking takes place at high temperatures. If the friction is very less, the moving object becomes very easy for us. The friction is the one which is the motion, opposing the motion of the object. So, friction is also produces the heat in the materials. The work done against the friction is converted into heat, and friction force is not a conservative force. Gravitational force is a conservative force. Conservative force means work done to move the object depends on the path followed, but friction force do not depend on the path followed, therefore called the non-conservative force. Another thing is, if you take the circular objects or spherical bodies, cycle wheels or bullock cart wheels, the wheels are circular in shape and having the radius r, and these car wheels, etc. When you are trying to move it forward direction, the friction force here at the bottom try to stop it. The friction opposing this motion, the result is that center of gravity from the top falls outside this point in contact. Rigid bodies have this perfect spherical surface, only point is in contact with the bottom of the ground, and as a result what happens is the object starts rolling. Rolling motion is a combination of the rotatory motion and translatory motion, and it happens only because of friction. If the friction is not there, rolling is not possible. It only has the sliding motion in the circular object also. and the rolling objects have the friction called as the rolling friction. The rolling friction is equals to again mu r into normal reaction here, normal reaction md, but no this frictional force here appearing trying to stop these particles at this place is a static friction actually. Then torque is acting on the circular object, torque which is rotating the circular object is torque equal to force into perpendicular distance. There it is 90 degrees, radius is r, the friction is Fs. So, torque is nothing but equal to Fs into n, n is nothing but equal to mg. So, this torque is the one which is making the circular objects to rotate or spherical objects, and more radius torque equal to force into distance, perpendicular distance r radius. More radius, more torque, more easily can rotate the objects, circular bodies. So, big wheels will rotate easily for the given frictional force. Big wheels means more radius, more torque means more easily can rotate. Bullock cart wheels are bigger in size, because of that reason only easy to rotation possibilities there. Car wheels are rotated for the small in size because for the stability, because they are designed for the high speed. When the high speed vehicles are traveling at turnings, due to centrifugal force, pseudo force, inertia of direction, they may overturn. To avoid that, the center of gravity should be close to the ground. Due to that reason that the car wheels are provided very small in size, small in radius, so that the center of gravity is close to the ground. This rolling friction is for the circular objects, and rolling friction is less than that of the static friction and kinetic friction. So, mu r is less than mu k, kinetic or sliding, which is less than mu s. Static friction is the maximum, and kinetic friction means limiting friction here it is, and that of compared to kinetic friction and rolling friction. Coefficients do not depend on the weight, because the frictional force equal to mu into normal reaction is mg. Mu is constant for the nature of the materials, roughness depends on the roughness. If you make the surfaces smooth, the roughness decreases, but perfect surface, smooth surface, if in contact, the molecules of this, the adhesive force takes place, the molecules of attraction between these two molecules take place, cohesive or adhesive depending on the type of the materials. Then roughness is there, means friction is more roughness. As the polishing takes place, more polishing, the smoothness increases, means roughness first decreases and then increases. Increases because the molecular force of attraction between the perfectly smooth surfaces. If you take the two glass plates perfectly smooth, it keep in touch, they stick hardly because of the electrostatic force of attraction. Next problems we have to discuss, and one more thing before this problem, if you take the inclined surface, on the inclined surface the normal reaction, on the horizontal surface normal reaction is mg. If you take on the inclined surface, the weight is mg, always acting downwards, angle of inclination is theta, and normal reaction is normal to the inclined surface, this is n, and this theta is the mg is resolved into components, this is theta means this is also theta, and the component mg in the opposite normal reaction is nothing but equal to mg cos theta. Normal reaction is balanced by mg cos theta, there is no resultant motion in this direction, and friction, it is trying to slide downwards because the component of the weight mg, that is mg sin theta, which is trying to pull downwards. So, friction force is there, means it opposes this motion, that is equals to Fs. Frictional force, if it is at rest means Fs, if it is in motion means Fk we have to use. This Fs is nothing but equal to mu into normal reaction, in n equal to mg cos theta. On the level surface n equal to mg, on inclined surface n equal to mg cos theta, that point you have to remember. Another thing is, if the object is at rest, the friction force is equals to mg sin theta. Unbalanced force is nothing but equal to along the inclined surface you take it. If it is already in acceleration downwards, then Fs it replaces with Fk, slight kinetic friction, and resultant motion mg sin theta minus Fs equal to m into the mass of this block into A we have to take. And one more point they will tell in the slopes 1 in n or 1 in 2 meters, 1 in 25 like that mentions. And the inclined surfaces are roads, inclined roads or hilly roads, if they mention 1 meter 1 in 20, 1 in 20 means height raised is 1 meter, in when you travel the distance equal to 20 meters on the inclined surface, that is called as a inclined surfaces measurement. They mentioned 1 in 20 like that, they mentioned means 1 meter height you are raising up as you travel the distance equal to 20 meters inclinations. That is for the slopes they mentioned, but slope means tan theta. Tan theta is equal to 1 by this part, this is nothing but equal to root of 20 square minus 1 square you will get, that is equals to tan theta. Tan theta equal to 1 by this opposite side by adjacent side. Next, the problems. Concept question are also important, please go through the concept problems, but very few problems come from this topic, only one problem very hardly. Next, 67th question. There is a book between the two hands. Book is held between the two hands. So, the weight is pulling the book downwards between the two hands, they are holding it like this. The book is trying to fall downwards, weight is acting downwards directions, but if we are applying the force from the both sides F and F, and between with your hand and book there is a friction force, both sides you are finding. The total force upwards equal to total force downwards when the book is at rest. The normal reaction, normal to surface, the action is nothing but reaction is nothing but equal to n only we have to take it as equal to perpendicular surface force, that is the normal reaction. On the level surfaces n equal to mg, but n in normal reaction need not be the same formula always, same symbols need not be. Normal reaction symbol sometimes they will take as a capital R also, careful with that terms. Next, book between the two hands is held and it is at rest. The weight of the book is given, sometimes they will give the mass, you have to be careful with that, and force you are applying perpendicular to the surface is 40 newtons with hand each, and you are asked to find out what is the value of the mu. Here upward force equal to downward force at rest, upward force is nothing but equal to 2 times the frictional force, that is mu 2 Fs equal to total weight downwards is mg, mg itself is 20 newtons. So, we are Fs equal to mu into normal reaction, normal reaction here is F. So, we take it as equals to 2 mu F equal to mg, mu we want. So, mu equal to mg by 2 F, which is the substitution you will get mg, mg itself is 20 and 2 into F we are applying is 40 newtons, the result is 0.25. Coefficient of friction do not have units and dimensions, just a number. Next, similar problem they may ask on the wall. A book is pushed towards the wall, they may mention. The weight is acting downwards, trying to slide downwards, and force applied is for perpendicular surface. This itself is normal reaction. And if it is trying to slide downwards, so the friction is acting downwards, upward direction F is equal to mu into normal reaction, means mu into F. At stable condition, what you take is equilibrium condition, upward force equal to downward force, F is equal to mg. Fs means mu F equal to mg. Previously, what I got is 2 extra number comes, here 2 do not come. So, if you are applying the force on the surface of the wall or board, they mention like this, you are applying the force like this, not sliding downwards. If the force is not sufficient, it will slide downwards because of the weight acting downward direction. And if the perfect smooth surface is there given, then mu is 0. If mu is 0, they will ask you how much force is required to stop it. If mu is 0, what happened to the force required is this mu F, F is equals to mg, either here or here condition if you take a F is equal to mg, means mu F equal to mg, F equal to mg by mu. If smooth surface you have taken mu is 0, that means this becomes equal to mg by 0, and F equal to mu tends to 0 means F tends to infinity, 1 by 0 is infinity. Infinite force is required to stop it if the friction is not there between the surfaces. So, that means you cannot stop it only. Friction is compulsory required. Friction is called as a necessary evil, means it is required at the same time minimum number. More number is there means again it provides the loss of energies in the mission parts. You have to go through the points, the concept points of the advantages of the friction and methods of reducing friction also, and lubricants, what kind of lubricants are helpful, helping to reduce the friction. Next, question number 73. Here car is applied the brakes, and initially before applying the brakes the velocity is 72 km/h converted to meter per second by multiplying with 5 by 18, and it stopped at the distance equal to 30 meters, coming to rest, V is 0. You are asked to find out mu equal to how much. Whenever the object is coming to rest, you take the acceleration A equal to mu g. Coming to rest means retardation, we take it as a minus in the formulas. So, V square equal to u square plus 2s, s equal to ut plus half t square, V equals u plus at. All these equations wherever A is there, that you have to replace with A equal to mu g. It is a level surface, F is equals to frictional force equal to mu mg. What happens here is the relation we will get is because of this horizontal surface, there is no external force acting, just apply the brakes and coming here have to only sliding downwards or just to push an object on the ground and remove the force going on its own with initial velocity u and coming to rest after some time. The friction force opposing the motion moving is the forward direction. So, this friction is nothing but normal reaction equal to mg on the surfaces. Fs is nothing but equal to ma, we take it, A is the retardation. So, equating these two relations you will get is Fs equal to mu n, Fs is also equal to ma. Substituting these relations you will get the A equal to mu g condition, that is minus indicating retardation. And stopping distance equation from this V square equal to u square plus 2s is s equal to u square by 2a. This formula is important even for the other topics also. Stopping distance is inversely proportional to A and directly proportional to u square. A is a retardation here. More double the velocity, product distance becomes equal to 4 times. That means, if you apply the brakes immediately it will not stop. Next, that depends on the friction. Friction is the one which stops the, if you apply the brakes, wheel stop rotation, but friction between the wheels and ground is the one which stops the car. So, equating from this A, substitution of this mu equal to u square by 2 s g you will get a, and u square is 20 into 20 by 2 into the distance, stopping distance 30 meters, and g is 10 given in that question. I did not mention here, maybe the calculation will give mu equal to 2 by 3. Next, question number 98, it is on the inclined surface. On the inclined surface, mass is given as 10 kg, theta equal to 6 degrees angle of inclination, and inclination they may give the horizontal with vertical. Vertical means here you have to be careful, this is 90 degrees. So, theta means this other angle becomes equal to 90 minus theta, and mu is 0.2. I did not mention mu s or mu k, depending on the problems you have to modify this. G equal to 10, A is equals to how much? Acceleration, downward acceleration they asked. You have to remember the formula directly for this acceleration downwards. Downward acceleration is A equal to g sin theta minus mu cos theta. Direct formula also they may ask sometimes, you have to be careful with this formula, it is very important once. If it is pushed upward, just let it go up, then this minus becomes plus. This is a downward direction, upward means plus it becomes. Friction force is mu into n equal to mg cos theta. On the inclined surface, n is equals to mg cos theta, friction force equal to mg sin theta means this is Fs you have to use. Stationary means Fs, Fs equal to mu n. If Fk means equal to mu into normal reaction, mu becomes equal to mu k for the sliding objects and mu s for the stationary objects. This force equal to this force if it is at rest, but already sliding downwards we have to check up this, then in that case mg sin theta is more than friction force. The mg sin theta minus friction force is nothing but equal to ma. M is the mass of this block on the inclined surface. So, Fk equal to mu into normal reaction equal to mg cos theta, ma resultant force equal to mg sin theta minus Fk, that is mu mg cos theta. Substitute the values, you will get mm cancels, acceleration is g sin theta minus mu cos theta you will get, and substitute the values of this theta. Theta is 6 degrees and 60 is root 3 by 2, cos 60 is half 0.1 into half is 0.1, this is root 3 by 2. Root 3 value is 1.732 minus 0.1, the result is 7.66 meter per second square, downward acceleration. If the friction is not there, smooth surface they mentioned like mu equal to 0 in the expressions, then acceleration A equal to g sin theta it becomes. And in this inclined surface, if they ask how much time it is taking to come down, the distance traveled to come down, and while going upwards, so we just push at the bottom how much distance traveled. In all these expressions, A we have to use this relationship, and S equal to ut plus half at square, V equal to u plus at, S v square equal to u square plus 2s. All those expressions A you have to replace with this while coming down, and A equal to upward directions if you have taken means A equal to g sin theta plus mu cos theta. This is upward motions, that is downward motions. These equations of motion you have to substitute the same values, same symbols, same formulas. Next, question number 105. It is also inclined plane. You are given the rough surface, smooth surface, two comparisons they are given. This is very important problems, please you just go through this problem. Can be asked for any competitive exams. Downward motion you are asked is downwards, they are sliding downwards on the two different surfaces, rough surface and smooth surface. Smooth surface goes very fast compared to rough surface. So, rough surface goes slowly, takes more time. And what is the formula for the time? S equal to ut plus half at square. Starting from rest, S becomes equal to half at square. S equal to ut plus half at square, S equal to half at square, because starting from rest u is 0. U is 0, and distance travelled on the inclined surface is S in both the cases same length. So, S equal T equal to 2S by A becomes. A is for the rough surface AR, smooth surface AS we have to use. Yes, 2S is same, taking the ratio to length cancels, 2 cancels, left out the relation is T rough surface by T smooth surface, they are again equal to N. We take some fraction number N. In this question there is given the twice, 2 times means 2 we have to take. And acceleration on the rough surface already we have taken this g sin theta minus mu cos theta. On smooth surface mu is 0, they will get as g sin theta only we will get. Taking the ratio of these two and modifying this sin theta taken to the below this, the expression result becomes equal to in terms of tan theta. You better remember this relation directly. Very important problem it is. Mu equal to tan theta into 1 minus 1 by n square. N is a fraction that time relationship, rough surface by smooth surface how much. Here in this case is given as 2, means 2 square is 4, 1 minus 1 by 4 becomes equal to result is root 3 by 4 is mu. Next 119, part of the chain hanging from the table and is at rest. Total mass is m, total length is capital L. To capital M, capital L are the total mass and length. Hanging portion is small m and small x. Mass is proportional to length for the uniform length. If you have taken for the chain, rope, etc., mass is proportional to length. This weight mg is pulling it downwards, but friction force is stopping it. The remaining portion is some portion is on the top surface, some portion is downwards. Friction is stopping it. The fraction hanging is m and with the length L, then total mass m minus m is the remaining mass into g. So, normal reaction is nothing but equal to downward force. Downward force is this mass into g, m minus m into g. Frictional force is nothing but equal to, friction is nothing but equal to mu into normal reaction, and it is balanced, not moving, means this friction force is equal to downward pulling force, that is equals to mg. F is equal to mg and is at rest. Mu into m minus m into g equal to mg. Taking the expression, you will cross multiplication, mu you will get, you have to remember this formula also directly. Mu equal to x by L minus x. They may give the x symbol differently, you have to check up that, and they may give the percentage, means what? Percentage of fraction hanging they may ask. Percent fraction hanging means this is called as the fraction hanging. Just manipulate this same equation, you will get this x by L equal to mu by mu minus mu by mu plus 1. Percentage if they ask, no, into 100%.